Okay, so hi everyone, welcome to today's class. For those of you who are watching this from YouTube, please please make sure that whenever you are doing an exercise that we are doing, you pause the video because I will already edit the video and dia akan lompat terus kepada jawapan lah. Okay, so please make sure that that you do every single exercise and example that has been taught here. Okay, because actually today's class is very important. Okay, we are going to be looking at the first derivative of a function, otherwise known as dy dx. Okay, this is the first derivative. Ini dalam bahasa Melayu kan, first derivative is called a terbitan pertama. Okay, basically it means when you differentiate a function one time. Okay, so we call it the first derivative. So actually, a certain function lah. So we have learned previously, for example, if you have a function kan 3x squared, I can find the dy dx by using this process called the first principle. Okay, this is what we covered in the previous lesson. So I hope you remember this. The one that melibatkan x plus del x, okay, and all the nonsense that came after that. So that's the first principle. Okay, so and I want to remind you that differentiation is the process of finding apa yang saya panggil, this is called the gradient function. These are all words that you're going to see, especially in subtopic 2.4. Okay, y equals to 3x squared is the original function. Okay, is the original function. Some people will call it a curve function. Okay, or a line function lah, depending on whether it's a curve or a line lah. Tetapi once we differentiate, lepas kita differentiate, after we jalankan first principle, we can find dy dx, which is known as the gradient function. Okay, so in our lesson last week, we learned how to find the gradient function, alias the first derivative, alias the first time differentiation. Ada banyak nama ini, okay? It's called the same thing, so there's just banyak alias lah, okay? Trust the mathematics people to make something very simple so overcomplicated. Okay, just differentiate satu kali je. Okay, basically is that. So we learned how to do this by using first principle. Today, we are going to learn the shortcut method. Okay, and the shortcut method kan akan dipakai for this entire subtopic lah. Okay, 2.2 and 2.3. Okay, so get ready, So I'm going to use the same function as original, the original curve function 3x squared. Okay, when I differentiate this using the shortcut method, okay, so this is the shortcut method. If y equals to ax to the power of n, okay, this is the formula. Okay, so the shortcut method dy dx tanpa menggunakan first principle, this is the shortcut method, okay, will be nax to the power of n minus 1. Ia adalah seperti this power of n kan kamu bawa pergi depan, kasih darab. And then lepas itu kuasa kamu pergi tolak 1. I repeat, the n power, okay, that is with the x is brought forward. Okay, kasih darab di depan, darab dengan a lah. And then the kuasa yang kamu bawa ke depan itu di sana kau kasih tolak dengan 1. So what happens over here? If my original function is y equals to 3x squared, my first derivative alias gradient function alias first time differentiation, okay, same thing, okay, same thing, which is dy dx will be the 2 saya bawa pergi depan. So 2 times 3x to the power of 2 minus 1 will be 1. Okay, do you see that? The 2 you bring forward and then you multiply lah. So 2 times 3 will be 6. X to the power of 1. Itu power of 2 kan dia akan turun satu kuasa menjadi 1. And that's the shortcut method. Okay, that's the shortcut method. We turunkan the kuasa one time ke depan and then one time kita tolak 1. But actually 6x to the power of 1 is just 6x. Okay, so maybe at this point kan you are asking yourself, if there is a shortcut method kan, why did we spend our entire Chinese New Year answering the first principle questions? It seems like a waste of time, right? Like, hayo, the first principle kan boleh mati kan kamu buat. I saw some of your homework kan, like some of you wanted to die doing. Okay, some of you like, oh, okay, because it's like all this ada banyak del ini kan sampai kau punya del kan terus nampak macam berudu sudah. Okay, but So first principle is a different story lah. Okay, first principle is a different story. You need to know how to do the first principle, especially if you're going to higher level mathematics lah. Okay, first principle is actually very important. Sorry everyone, I forgot to mention, since I'm at home, you kind of need to turn on your cameras. Yeah, so that I'm not talking to my ring light alone. Wah, kenapa kasih punya ring light? Thank you, thank you. Saya sudah upgrade jadi YouTuber berjaya sudah. Yeah, so anyway, please pakai your tudung everything and turn on your cameras so that I know that we are working together and I'm not just talking to my ring light. Okay, so, okay, thanks. Tapi belum lagi pasang kamera. Okay, so this is the basic thing lah. Okay, when we bring down the power, okay, we have to minus the power, and this is kind of the shortcut method. And you can use that in all situations. Okay, let's do a couple first lah. Why don't you take a look at question number 1? Okay, let's do question number 1A. I'll do it together with you, and then after that we will, and then after that you can try on your own. So let's say the function is y equals to x to the power of 4. Okay, so original function is this. So the first derivative, I'm going to say this a lot of times today until you're very bosan. Okay, the first derivative alias the gradient function alias the first time differentiation, which is also known as dy dx, will be kuasa 4 ni kamu bawa ke depan. So 4 times x to the power of 4 minus 1 will be 3. Okay, and that's basically it lah. Okay, most of the time our differentiation is only one step. Okay, you just need to be able to see where to put the power, okay, and then how to power minus 1. That's basically it. Move the power to the front, power itu tolak 1. Okay, so that's question 1A. 2A, okay, will be y equals to 3x to the power of 4. So same thing lah, except that dalam case ini, in this case, there is no number in front, so kita darab 1 terus. But in this case, the first derivative alias the gradient function alias the first time differentiation alias dy dx will be 4 bring to the front, 4 times 3x to the power of 4 minus 1 will be 3. Then all you need to do is just 4 kali 3, kau akan dapat 12x kuasa 3. Okay, so the key to doing this is you need to do it as many times as you can sampai satu kali kamu nampakkan, kamu boleh tahu sudah what is the first derivative. Okay, without having to really think about, okay, pindah ke depan lah, blah, 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 blah. Kau boleh mentally do it lah. If you can mentally do the differentiation, a simple differentiation like this in your mind, okay, then you know that you've got it. Okay, so that's why you need the practice. That's why this kertas is so tebal. Okay, because there's a lot of questions. Okay. Okay, number 3. I'm just going to answer all the A questions just to give you an idea of how to do it. Okay, so y equals to negative 5x to the power of 4. Okay, totally nothing new here. Tidak payah kencang pun kerana ada nombor negatif. Okay, the first derivative alias the first time differentiation alias the gradient function is dy dx is 4 kamu bawa ke depan. Okay, the same principle. Bring the power to the front. 4 times negative 5x, but this time the power reduced by 1. So power of 4 will become power of 4 will become power of 3. Okay, and then all you have to do is just multiply the 4 times negative 5. Totally no problem. Darab nombor negatif saja. Okay, tiada apa-apa mau dikencang. So just negative 20x to the power of 3. Okay. Now, the problem comes when we have things like 4a. Okay, so this is what happens. So fx is equals to x to the power of negative 1. Okay, so this is where you need to pay attention. Number 1, I've already said, the first derivative alias the gradient function alias the first differentiation is also known as dy dx. Okay, but if your function is in fx begini, if the function is in fx, the first derivative is known as f prime x. Okay, it's the same thing, dy dx lah. Okay, just cara menulis yang berlainan. Okay, kenapa ada y, kenapa ada fx? That one you have to ask the people who did the question lah. Okay, but there's nothing. It's just different ways of writing the same thing. Okay, so we call it f prime x. Totally nothing to do with the functions chapter that you learned last year. Yang ada f kuasa 2x lah dan f negative 1x lah. Totally nothing to do. Tiada kaitan, tiada kaitan, tiada kaitan. Okay, this is prime, as in the comma on top. Okay, so we call this prime. Prime macam Optimus Prime or Prime Minister or whatever prime thing lah. Okay, so we call it f prime x. Juga dikenali sebagai dy dx, juga dikenali sebagai the first derivative, juga dikenali sebagai the first time differentiation. Same thing. Okay, but we still hold on to the same principle. How do we find the first derivative? Okay, power bawa ke depan. So the power is -1. So we bring to the front, we get -1 di depan lah. Okay, and then x. Okay, the power must always -1. Okay, must always -1. Doesn't matter whether it's a negative number or it's a positive number, the power always -1. So if the power is -1, then you -1 some more kan, you will get -2. Okay, now kalau setakat ini like jawapan akhir kan, okay, usually in exam they won't accept an answer like this lah. Okay, final answer cannot be power negative. So you have to bring the negative power down. So this will be -1 over x to the power of 2. How to change from this to this is something that you guys learned in Form 3, I think. If not Form 3 last year lah. Okay, power of negative is just that whole thing kamu bawa turun ke bawah. Okay, for example, x to the power of -1 is actually 1 over x to the power of 1. Okay, kenapa 1 di atas? Sebab nombor di depan adalah 1 kalau tiada nombor lah. If it is 2x to the power of -4, example. Okay, 2 kasih tinggal di atas. Sebab yang kuasa negatif adalah x. So x yang kau bawa turun. So be x to the power of 4. Okay, nothing new. Okay, nothing new. Just have to, well, try to dig up somewhere in the amount of Chinese New Year cookies in your brain to see that it's still there lah. Okay, I'm sure that somewhere in there you still remember how to do this. Okay, it's okay. Don't worry. Chinese New Year makes us all a little bit forgetful. Yes.
Kenapa dia power negative tu?
Kenapa dia power negative tu? Because okay, remember the principle of the shortcut? The shortcut is the power must always -1. Doesn't matter whether it's a negative number or positive number. So if the power is a positive number, 3, after it differentiate, the power become 2 lah. Because 3 minus 1 is 2. If the power is -1 sedia, after you differentiate, -1 minus 1 is -2. So no matter what happens, whether your power is positive or negative, the power has to be -1. But the thing is this lah, syaratnya adalah dia mesti sebaris. Okay, if let's say okay, take a look at this. Oh, tiada pula di sini. Alah, jahat tau. Let me see. Okay, fine. Let's say for example, I give you, this is a totally different example lah. So y equals to 4 over x to the power of 3. Okay, and then I ask you to find the differentiation for this. Find this differentiation. Okay, you cannot do this because the basic formula is dia mesti ax to the power of n. Dia mesti satu baris. No per nonsense. Okay, so if you get a question like this, what you will need to do is you have to make it one line. How do you make it one line? This power of 3, kamu bawa naik ke atas. So kalau di bawah, dia adalah kuasa positif. When you bring it up, it will become 4x to the power of -3. This and this is actually the same thing lah, cuma different ways of writing. But this, kita boleh differentiate. This, we cannot. Okay, because the power is at the bottom. So it's a big problem for us. So we have to bring it up. Okay, so what we will get over here is dy dx. Okay, once we get this, -3 bawa ke depan, darab dengan 4, x to the power of -3 minus 1 will give you -4. Okay, then you simplify from there. Okay, so you get negative 12 x to the power of minus 4. And then, as I said before, final answer cannot be power negative. No choice. Okay, this is the rules of the world of mathematics. So bongok kan, tapi apa boleh buat? Okay, so dy dx will be equals to negative 12 over x to the power of 4. Okay, notice that the negative 12, I don't touch. So the negative 12 got no power attached to it. Only the letters and the numbers that have a power attached to, a negative power attached to that particular letter or number kan, yang kamu kena bawa turun. Especially if it is a negative power. Okay, so the thing that will probably confuse you at this beginning stage, okay, is this power thing lah. Okay, which is why I want you to spend, say, maybe about 15 minutes. Okay, try to finish the rest of the A questions that I haven't covered, which is 6A and, sorry, have I covered 5A? Oh, I haven't covered 5A, but okay lah, you can use this to cover 5A. Okay, why don't you try 5A, 5A, 6A, 7A, and then all the B questions. Okay, for now, okay, so that you get less homework. Okay, yeah, so try it now, and then after that I will give you about 15 minutes to do this, and then after that we will have our very fun session of Mr. Marcus calling random people to give me the answer. Okay, 15 minutes, give it a try.
Yang 那个 number 4 why the answer macam lain oh. 4C. Am I wrong or what?
So Rajin. 4C. No, I just asked to do all the A and B questions lah. But if you want to do this,
okay. Bye.
Yeah, but the C answer is actually wrong. The C answer should be negative 3 over x to the power of 4. Yeah, this what is it? Number 4. 4C. I'm writing the correct answer lah. It should be negative 3 over x to the power of 4. This should be the answer for 4C, people. Okay, please take note of this. Thanks, Sean, for being very rajin. What you got to jawab yang soalan C. Not that difficult lah kan. Actually, once you get used to the idea, it's okay. Once you get used to the idea, actually, it doesn't matter what the number is. Just bobat saja kan. Easy. Yeah, I should also let you know that actually some of the answers in this paper is a little bit wrong. So trust the process. Okay, don't just trust the answer. If your process is correct, then you should be okay.
So, how do you do question number 7B?
Okay, that's a good question. Yeah, why don't we start with that lah? Okay, 7B. So you have fx equals to 5 over 2 and then the x lah. Okay, so the problem is the number that has the power, the thing that has the power is actually only x lah. So the number 2 over there actually is not a pengacau. So what you need to do is you only need to bring the x up. So which means that this will be 5 over 2, and then this will be x to the power of negative 1. Because down here is power of 1, kan? So when you bring it up, it will become power of negative 1. Okay, that will be still the original function. Okay, then you find the first derivative, which is f prime x. Use the same principle. So the number in front now is a fraction, which is 5 over 2. Also no problem, fraction only ma. Okay, so just bring it forward and minus 1 and then bring back the x power down. Okay, you will get the same answer as the answer shown over there. Okay, give it a try and see.
Thank you, sir.
All right. Okay, 5 more minutes, people. All right. You know what, guys? I just realized that there's no point in me asking for your answers because the answers are already there. It's like, What am I thinking? So, okay, any of you facing any problems with any particular question that you want me to like maybe discuss? Like, kenapa saya punya jawapan tidak sama dengan jawapan di dalam kertas? Anyone? If not, then I will continue.
Tiada, sir.
Tiada? You sure?
No,
Satu
sir.
orang tiada tu? Oh, okay, dua orang tiada means the whole class tiada. Okay. I want you to turn to page 2 first. Okay. Yeah. So if you realize, the page 1 and page 3 and page 2 kan, dia terbalik bah, kan? Lepas page 1, page 3, lepas page 3, page 2. Do you see that? Kan? So it's like, okay. Yeah, anyway. So, okay, so now what happens if you have a function that is longer than just one term? So ini kan y equals to 3x squared, which is probably my favorite one. So this is what we call, this is one term lah. Okay, so what if you have a longer function? This is very normal. Okay, what if you have a longer function, for example, y equals to 3x squared plus 2x plus 4, contohnya. Okay, so this one has 1, 2, 3 terms. One term, one term, one term. So there are 3 terms in this one. Okay, terms. Okay, sebutan lah, terms. Okay, so what do you do when a function, okay, or an equation has more than one term and you want to differentiate it? Doesn't matter. Okay, do it separately and then combine them together in the end. Okay, let me give you an example. Same example as just now. 3x squared plus 2x plus 4. So you differentiate each one separately. So when I differentiate this, okay, I will get 6x. Begitu sajalah. Okay, how about if I differentiate 2x? If I differentiate 2x, I will get 2. Okay, and if I differentiate the number, I will get 0. So my differentiation dy dx will be equals to 6x plus 2. Don't need the plus 0 lah, tak payah. Ini saja jawapan saya. So you differentiate them separately and then at the end of it, you bring it together. Okay, some of you may be asking, macam mana ini differentiate boleh jadi begini dan ini differentiate boleh jadi kosong. Okay, so 2x is actually 2x to the power of 1. And if there's no power, then the power is 1. So when you differentiate, 1 kamu bawa ke depan. So 1 times 2, x to the power of 1 minus 1 is actually 0. Kan? 1 minus 1 is 0. So 1 times 2 is 2. 2x to the power of 0 is actually 2. Okay, so maybe just a short note over here lah. Okay, if y equals to ax sahaja, no power, this power of 1, so dy dx equals to just a. Okay, any case like y equals to 3 over 2x, so dy dx, the differentiation of a power of 1 is just the number in front. Okay, if y equals to x, dy dx, ini masih power of 1 bahkan, so the dy dx is just 1. Because tiada nombor di depan x bahkan, so the number is 1 lah. Okay, so this is point number 1 you need to take note of. If the function is just a number, okay, so when you differentiate dy dx, the answer will be 0. This is the second thing you need to know. Any differentiation of a number is always 0. Okay, if y equals to 4, dy dx is 0. If y equals to 6 over 5 negative, dy dx is also 0. Doesn't matter whether it is a singular number or a big fraction. As long as there is a number, no x, no power, okay, the differentiation is 0. Okay, and then, sorry, another one, turn to page 3. Okay, turn to page 3. I just want to highlight this to you lah. So if you take a look at question number 9a, okay, 9a, so y equals to x squared plus 5 over x. Okay, so this is the equation they give. Now this one can lah, tiada masalah mau differentiate lah. The 5 over x, you need to separately differentiate. But before you differentiate, you need to bring the power up. So you get 5x to the power of minus 1. Baru kamu differentiate. Okay, so I just want you to take note of this. Okay, and then question number 11a. Okay, so sometimes you will get this kind of funky functions like this lah. X cube plus 5x minus 6, dan lepas tu per x lagi kan, mengadap-ngadap betul. Okay, so some situations like this, what you can do is you can split the whole thing up. Okay, kamu boleh bezakan, kamu boleh pisahkannya. So this will be x cube over x plus 5x over x minus 6 over x. Then this one you find that you can actually simplify them. Okay, one by one. Okay, so ini akan jadi x kuasa 2. So ini kuasa 3, ini potong. This x and x will become just 5 lah, because the 1 will be potong. And then the minus 6 over x, you can bring it up to become minus 6 to the power of x minus 1. And then you can differentiate this. This is still the original function, people. Saya belum differentiate lagi. Okay, you know that you have differentiated bila dia punya power kesemuanya sudah kamu kasih turun 1. But selagi dia punya power masih begini-begini, belum lagi kamu kasih turun 1, okay, it has not been differentiated. Okay, so 11A and 12A work around the same principle. Split everything, baru kamu, in Chinese they say ye chen, so you just potong, okay, kasih bundarkan. Okay, baru kamu differentiate. Okay, so same thing, please try all the A questions first, everybody, just the A questions first, okay, from number 1 to number 12. Okay, Sean laughing there. Okay, just the A questions first, number 1 to number 12. Oh, sorry, I should also mention, oh my goodness, sorry, banyak pula saya kena mention. Okay, 6A, actually, if you take a look at the example they give, if they give like this, y equals to x plus 1 and then x minus 6 bahkan. Ini kamu tidak boleh buat apa-apa dulu. Jangan dulu buat apa-apa. You need to multiply as how we do. So x squared plus 6x, minus 6x plus 1x minus 6. Okay, ini masih lagi y. And then y equals to x squared minus 5x minus 6. Baru kamu boleh differentiate. Okay, so get it into this format, get it into this bentuk first lah. Okay, sebelum kamu differentiate, because the principle behind this is you need to have, different terms, then you can differentiate them separately. Okay, so let me give you maybe, gosh, okay, I give you 20 minutes lah. Okay, try to finish all the 12 questions in 20 minutes. Actually 15, yeah, you know what, we should try for 15. Okay. 15 minutes, try to finish all 12 A questions.
Sir.
Yes.
Yang 11A kan. We know
Okay.
the 11 example where the 4
11 example. Where did the 4 come from? Okay, so
I mean
macam saya
where
cakap
the
tadi lah.
4 go. Kan dia hilang tiba-tiba.
So x squared plus 4 plus 5x to the power of minus 1, right? So this one differentiate become 2x. Ini differentiate become negative 5x power negative 2. Ini remember I said just now, when you differentiate a number,
Oh yeah.
what do you get? When you differentiate a number, it becomes 0. There's nothing happens from there because they're the x. So in order to differentiate, there must be an x. If there's no x, then it's just automatically 0.
Okay, thank you.
All right.
Sir, for question 7A, does it have to be factorized until like what the answer is? Can I just write can my final answer be 2x plus 8?
Oh, cannot. How can it be 2x plus 8? Where do you get the 8? Oh, yeah, can.
Have to factorize again.
Let me see. Hold on. No. The answer is actually 2x plus 8, but you will definitely need to expand it first. I think the idea behind this is not that you realize that there is actually no shortcut to this. Whenever you see things like this, the first thing you need to do is expand it first. So you get x squared plus 8x plus 16. Then of course when you differentiate it, then you get 2x plus 8 lah, which is the actual answer. So you're asking whether you need to factorize like this, right? Is that your question?
Yeah.
Because this is the answer given. Okay, no need. If you give me like this also can. This is just the same way of writing the different way of writing the same thing. So totally no problem. You don't have to follow.
Okay, thanks.
All right.
Sir, for 11a, is it really plus 2x plus 6 over x squared? The answer.
Didn't I already answer this? Hold on.
Oh, yeah.
11a.
Yeah.
2x plus 6 over x squared, correct. Because, okay, so this is the equation, right? Once you you get x squared plus 5 minus 6x to the power of negative 1. Is that correct? Did you get that? Okay, so when you differentiate x squared, you get 2x lah. Okay, when you differentiate 5, you get nothing. Okay, this one, don't forget that there's a negative in front of the 6, you know. So when you bring the negative 1 forward, negative 6x to the power negative 1, right? When you bring the negative 1 forward, the negative 1 will multiply with the negative 6. And then the x will be minus 2. So you will get plus 6x to the power minus 2. Then you bring the x to the bottom, so it'll be 6 over x squared. Positive lah, plus.
Oh, yeah.
Okay, so good that you caught that because this is a very common mistake. So a lot of people will kind of forget about this. You just bring in front of the 6, but you forget to see that in front of the 6 there's actually another negative. So be very careful with that.
Okay, thank you.
Right. Good for you.
Sir.
Hi Adam. Hi. Yes.
For question 7, how the answer can become 2 in bracket x plus 4?
Oh, okay. So this is ini kan soalan si Celeste tadi ni. Kau tengok. Okay, I hope you can see the screen now. So kau nampak di screen kan. Lepas kau jawab begini kan. This one actually is the answer lah. Okay, kamu boleh juga kasih faktorkan. You can factorize the 2 out. Then kasih biar in the bracket x plus 4. Kamu dapat ke ini? 2x plus 8. Did you get that?
Yes.
Okay, so actually kamu boleh kasih tinggal jawapan begini. Tapi banyak jawapan di dalam kertas ini dia mau kamu faktorkan bah. So you take out the 2 lah and then after that you put the x plus 4, which kalau kau tanya saya rasa tidak perlu lah. It's unnecessary. You can just leave the answer sebagai 2x campur 8 pun tiada masalah.
Okay, thank you, sir.
Okay, alright. Okay, good job. Alright, everyone, let's continue. We're going into page 4. So this is slightly special stuff. Oh, you know what? No, let's not go to page 4. Okay, let me do page 4 with you another day. Okay, turn to page 9. Sorry, I'm laughing because it's so funny. Okay, page 9. Unit E. Okay, Unit E. Alright. So this is another different type of function. So first of all, we spoke about functions that have one term. Okay, and then secondly, we spoke about functions that have more than one term. So 3x squared plus 2x plus 5. Or sometimes there are equations that involve things that you have to expand. Okay, x plus 2, or even things that you have to simplify. Okay, x squared plus 2x minus 4 over x. Okay, so these are so far what we have discussed. Now, there are other types of functions, okay, which is what I wanted to cover in the second hour lah. Okay, so this is one type of function, is which we call composite function. Okay, now this composite function, basically, it is a function that has a power that is bigger than 2. Okay, at this point. So if you take a look at question 1a, question 1a, the composite function is y equals to x plus 3 to the power of 4. Now, if this was to the power of 2, tiada masalah. You can expand it, and then after that differentiate one by one. But how are you going to do power of 4, You want to do what? X plus 3, lepas itu x plus 3, lepas itu x plus 3 for 4 times. You know what kind of nonsense you're going to get? You're going to be like, okay, ini darab ini, lepas tu ini darab ini, lepas tu ini darab ini, lepas tu ini darab ini, dan lepas tu ini semua darab dengan ini dan ini. So it's going to be like one very long thing lah, which we cannot. Okay, it's totally mindless if we do this lah. Okay, kalau power of 2 masih boleh tahu. Just 2 brackets is okay. But if you have 4 brackets, 20 brackets, okay, you're going to die trying to expand it. Okay, so that's why there is a special rule which we call the chain rule. Okay, and this works with composite functions. Okay, so when you have composite functions, okay, so the chain rule now works this way. So let's say y equals to ax to the plus b to the power of n. Okay, this is the general formula, ax plus b to the power of n. So the first derivative, or dy dx, or the gradient function, or the first time you differentiate, okay, same thing, which is the dy dx, okay, it will be same principle. The power you bring forward. So n ax plus b to the power of, you do the same thing in the power, you minus 1 the power, n minus 1, but you add one other thing. Okay, you see the number a over here? Okay, the number a, kamu multiply di sini. So a times n, and then the bracket, and then the power you reduce by 1. Kalau ada number a, okay, if there's no number a, the number is just 1, then no need to bother lah. Okay, so this is how we would differentiate it. Now, this one, okay, I need to mention, all this dy dx kan, tiada formula ini, okay, you have to know it lah. Okay, there is no formula that, okay, ini boleh dijadikan panduan. Tiada, guys, the panduan doesn't exist in your formula book. Okay, you have to know this. You have to know this method lah, okay, which we call the chain rule. Okay, so let's do one example. So 1a, if y equals to x plus 3 to the power of 4. So kalau kita bandingkan dengan ini, ax plus b, a-nya adalah 1, b-nya adalah 3, and the kuasa is 4. So the first derivative or the gradient function or the first time you differentiate or dy dx, okay, is, what is the number a? The number a is 1. Okay, so 1 times 4, because you're bringing the 4 forward, and then the bracket kamu kekalkan saja. Nothing changes in the bracket. Okay, but the power now becomes 3. And that's why 4 times 1, you get 4x plus 3 to the power of 3, and you leave your answer like this. No need to busybody to open all the bracket and make your life difficult. Tak payah. Okay, just do the rule, bring it down, change the power, done. Okay, 2a. Y equals to 2x plus 3 to the power of 4. Okay, now there's a number in front of the x. Okay, so slightly different situation lah. Since there's a number, so the first derivative alias the gradient function alias the first time you differentiate alias dy dx is, what is the number a? The number a is 2 times with the power, which is 4. And then 2x plus 3, nothing in the bracket changes except the power. So the power become 3. And then what do you do with these two numbers? You multiply. So you get 8, 2x plus 3 to the power of 3, and you leave it there. Don't kacau the power of 3. No need to make your life difficult. Okay? Likewise, same thing goes with question, I'm going to do question number 5 terus lah, 5a. Okay, 5a, y equals to 3 over 4x plus 5 to the power of 3. Okay, so think about the form. The form that we want is begini dia punya form. Okay, saya mau dia macam ni supaya saya boleh guna this panduan. Okay, so what you need to do, oh no, where am I going? Sorry. Okay, okay. So what you need to do is, you need to, you should be able to see that this 3 and this 4 kan is just a number in front. Okay, that you can leave it in front. Sementara itu, this x plus 5 to the power of 3, you can bring it up. So what you will get, okay, is 3 over 4 kasih biar saja, don't need to bother. It is the x that I want to bring up. Okay, so what I will get is, I will get x plus 5. Since down here is power of 3, when you push it up, it will become power of minus 3. And then you do the exact same thing when you want to find dy dx, alias the first derivative, alias the gradient function, alias the first time you differentiate. Do the same thing. What is the number a? Number a is 1 lah kan? Because there's no number in front of the x. So okay, so 1 times, tapi ada 3 over 4, kasih kekal lah 3 over 4. Then you bring the minus 3 to the front. And then it will be x plus 5 to the power of minus 3 minus 1 will be minus 4. Okay, so what happens over here, I'll get minus 9 over 4 x plus 5 to the power of minus 4. But as always, our final answer cannot be power negative. So you need to bring the negative 4 power back down to where it actually belongs. So you get negative 9 over 4 x plus 5 to the power of 4. And that's your final answer. Okay, so get used to things that kamu boleh main, sumbat stuff at the bottom one, no problem. As long as yang ada di bottom terus stay di bottom lah. Okay, so be flexible about this lah. Okay, itu yang menjadi kebimbangan saya paling utama ini. Okay, so same thing, do all the questions A and B. Yeah, I'm not going to be able to finish everything today lah. I think it's not fair. I can feel myself yawning. I don't know about you lah. Okay, saya rasa ada some of you also probably yawning kan. That's why you turn off your camera kan. Okay, so anyway, try questions A and B for both number 1 to number 5. We are on page 9. Bagi mereka yang tidak sedar, kita berada di mana? Kita berada di muka surat 9. Okay, so questions A and B, and then maybe I'll give you about 15 minutes also to do this, and then I'll see if we can continue from there.
So, yang 5B need to times the A or not? The 2.
5B. Yes, of course, must times the A. So you get 2 times 4 over 5 times negative 6.
But I didn't times 2, but I get the same answer.
How do you do that? Let me see. Y equals to, so 4 over 5, then you get 2x minus 3 to the power of negative 6 lah kan. So the dy dx will be 2 times negative 6 times 4 over 5. And 2x minus 3 to the power of negative 7. No? Oh no.
It's negative 48 over 5.
Yeah,
if
I know.
I didn't times 2, then it's negative 24.
And you should times 2 though.
Yeah, the answer didn't times 2.
Yeah, you should times 2. So, like I said lah, trust the process. Don't trust the answer. 5 kah itu, Sean? 5 kan? So 5B should be negative 48 over 5. Negative 48 over 5, 2x minus 3 to the power of 7. Okay, and 5C should be, what is it, Fadila? 5C, should be what?
5C, 30 over 3x negative 4.
30, okay, 30 over 3x minus 4 to the power of 5. Yeah, this looks about correct. They probably forgot to multiply the the negative, the A, sorry, in the answer. Okay, do you guys still need some more time, or are you guys like already done?
Belum lagi.
Okay. I give you maybe about 5 more minutes.
Sir,
Yep.
for question 3C, right? The final answer, right? The power is it 2 or 3?
3C, okay. 3C should be 12 times 2x plus 8 to the power of 2.
Right.
Yeah.
Thank you, sir.
Okay. So you know what? Actually, this is progress now. If you are confident with your answer so much that you can dare to say that the answer in the book is wrong, kau pro sudah lah. It's true. Okay. If you dare to say the book's answer is wrong, okay, means you're pro already. Means kau sudah memang kau boleh buat macam yang betul. Okay. Let's continue lah. Everyone, I need to turn to page 12. Sorry, we're jumping all over the paper today. Okay, because there's a lot of like okay. Yeah, so let's do this is the last thing for today. Okay, I promise this is the last thing for today. Okay, because when is our next class? Thursday. On Thursday we will have a different set of problems that we need to talk about. Okay, so dy dx is known as the first derivative, okay, or the gradient function. Yeah, sorry, I was writing this and then I realized that it didn't transfer over, sorry. Or the first differentiation. Okay, so I said this many times throughout this entire class today, that I hope you've gotten it, like, sudah masuk lah. But now this last thing we're going to look at is how to find the second derivative. Okay, the second derivative, also known as the second time you what differentiation. Okay. Now, this second derivative is not a gradient function. Okay, there is another special name for it, but I will tell it to you later. So how do we write the second derivative? Okay, if your original function is y, then first time you differentiate, you get dy dx makan. Okay, the second time you differentiate, it is known as d2y dx2. Okay. Don't ask me why the square is in different places. How come it is not dy squared over dx squared? Okay, it's not. Okay, for now, please be kind to me and just accept it as it is. It is called d2y dx2. If your original function is fx, first time you differentiate is f prime x. So second time you differentiate is known as f double prime x. Okay, so usually at this stage, certain students they will ask me, so sir, is there such a thing as third derivative, fourth derivative, 10th derivative? God, okay, there is until 100 derivatives if you want. Then if like that, sir, what about the prime? If 100 times you do differentiation, means it's f prime for 100 times, is it? I said, yeah, lor. That's what it is, lor. It'll be f prime. How many times you want to differentiate? That's how many times you have to prime it, lah. So if you prime twice, then you differentiate twice. If you prime 10 times, you differentiate 10 times. Okay, so how do you read it? It's read as it is, lah. F prime. Okay, until kamu punya mulut mau tercabut sudah dengan tu perkataan prime. Okay, but anyway, let's limit our discussion to just second prime lah. Okay, so the second prime. So the step is the same. Okay, for example, if you take a look at the example given over there, fx is 3 minus 2. Oh, sorry. Okay, I cannot do this for you just yet. Let me see. Okay, let's do number 1 lah. Number 1 is easier. Okay, number 1, y equals to 2x cubed plus 4x squared minus 6x plus 3. So you differentiate once. This is the easy differentiation lah. Okay, we differentiate once, 2x cubed will give you 6x squared. This one will give you 8x minus 6. 3 differentiate, you become 0. Okay, second derivative, oh my goodness, second time you differentiate. Please notice macam mana saya tulis itu squared. The first square is next to the d, the second square is next to the x. Okay, jangan terbalikkan, tidak boleh terbalikkan. Okay, so you differentiate these 3. Okay, jangan lagi tengok yang asal. So you differentiate the differentiation is the second derivative. So 6x squared will give you 12x plus 8x will give you 8. Minus 6 will give you 0 because you cannot, a differentiation of a number will always be 0. So that's how we do it. So you differentiate the differentiation. That's what the second derivative means. Okay, you differentiate one time, differentiate again. Okay, but all the rules of differentiation still apply, whether it is composite function, whether it is a simple function with many terms. Okay, all the rules still apply. Okay, so I want you to do question 1, 2, and 3 first. Sorry, just question 2 and 3 lah. Okay, for now. I want to skip question 4 first until a more suitable time. Then I will talk about question 4. Okay, just do number 2 and 3 first. See if you can get the hang of the second derivative. Okay, can everyone? Yeah.
Cannot also.
Cannot.
Why, which one you cannot?
Very confused.
So
Number 2.
Number 2 Okay, let's try. Okay, so fx equals to 2x squared 40 minus 3x. Can anybody suggest? Anybody who thinks that they have done this, can you suggest how I want to do this?
Darab masuk. Times A.
Okay, you darab masuk dulu. So you darab masuk, you will get 80x squared minus 6x cubed. Okay, so this is still fx lah. So you differentiate the first time, you get 160x minus 18x squared. Then you differentiate the second time, this one you will get 160 because x is power of 1. Okay, and then minus 36x, this one 2 minus 1 will be power of 1. So that's it. Okay, so I suspect that those of you who didn't know how to answer this is because you saw the bracket and then terus like, oh, okay, start sudah. Make it simple, okay? Just multiply it in, then you get kamu boleh dapat satu bentuk yang actually kita pernah tengok. Just 2 separate terms. Number 3 can have. Number 3 should be quite easy lah. Okay.
Still trying.
So what does f prime bracket 0
mean? Okay,
Yeah.
so what does the 0 mean? Okay, so what do you get for f prime prime? Can you tell me?
I haven't do yet. I got
Okay, it's okay. So fx is 4x minus 1 power of 5. So you differentiate the first time. Okay, the number is 4. And then the 5 you bring down to the front. Okay, and then 4x minus 1 to the power of 4 lah. Okay, so this will be 20 4x minus 1 to the power of 4. This is still the first time differentiation. When you second time differentiate, okay, the number 20 is still in front. The number 4 you still have to bring out, So number 4 and then the power of 4, but the original 20 has to remain there. Mesti didarab juga. Okay, then you have 4x minus 1 to the power of 3. So you bring the number that is inside the bracket must still be, we carry the same rule lah. Doesn't matter whether there's a number in front of the bracket or not. We still have to bring it out first. Okay, so this will give you 16 times 20 is, I don't know, 320? Is it 320? I don't think so.
Yes, sir.
320, 4x minus 1 to the power of 3. So this is f double prime x. Now, what if we ganti x with 0? That's basically what this means. You substitute the x with 0. So you get 320 times 4 to the 4 multiplied by 0 minus 1 cube. Iya, gitu. Ha!
0 is the object, right?
Correct. 0 is the object. So it's still pretty much the same thing as what you learned when you were in Form 4. Okay. Except that actually I wasn't supposed to cover this today, but okay, since we have this question over here, might as well just cover lah. Okay, so you count this in your calculator, you get negative 320. Okay, memang cun-cun lah dia punya jawapan. Okay, but like I said lah, we'll take it one step at a time. The most important skill for today and tomorrow, since our class now is tomorrow kan, the most important skill is not really so much about the mengganti masuk the nilai X lah. Okay, itu kita boleh belajar kemudian. The most important thing today is you need to know how to differentiate first time and second time. The first derivative and second derivative. We are not done, people. There is still a few more things that you need to learn, but I need you to get used to this idea before I teach you the second half of this. Okay, so, kita sudah cover maybe about 70% of the derivative world lah. Okay, there's still another 30% more to go, which we will cover in the Thursday class. Okay, so to help you, to get used to this, this is your homework for today and tomorrow. Okay, which needs to be submitted by Wednesday night. Yeah, Wednesday night. Okay, so page 41 in your exercise book, self-exercise 2.3, questions 1 to 4. This is probably the easiest differentiation everybody can do. Okay, then page 43, this is the one that involves the composite functions. Okay, yang ada kuasa yang lebih daripada 2. And then page 50 is the second derivative, d2y dx2. Okay, so please answer all these exercise questions and hand it in by Wednesday night, which is usually 11:59. But every time I say Wednesday night, sure got people who hantar late one, so it's okay. All right, so no worries about this.